Thank you. Okay, so I'm going to talk a little bit about our outreach program in Portugal and about some particularities of it, and then Paul asked me to focus on this interface with the civil protection. Okay, so first some characteristics about our seismicity. So Portugal is in the very southwesternmost tip of Europe. It's next to this plate boundary between Eurasia and Africa. And actually, we have a huge, most part of our territory is underwater. And we have a huge domain offshore, and then we have the Azores. So, of course, the Azores are a triple junction. They are a place of very active seismicity and volcanic activity. And there's a number of magnitude up to 7 earthquakes in the last century. And then we come through this Gloria fault, which is a very large strike-slip fault in the oceanic domain, with some very large earthquakes like this magnitude 8.3 in 1941. And I find it very interesting, actually, magnitude 8.1 in 1975, clearly in the intraplate oceanic domain. And then we move on to this region, which is the region that we deal with most often because we are in the mainland. And I'm going to move here next. And we have some very large earthquakes offshore. We have the 1755 Lisbon earthquake, which destroyed Lisbon, which is one of the largest cities in the world at the time, capital of an empire. And it was an earthquake that really changed the way we look at earthquakes in many ways, we as a society. And it changed the history of our country, so it was a very marking earthquake. But it's not only that. So we had, for example, in 1969, so about 50 years ago, a magnitude 7.8 offshore. And it's not straightforward to understand these earthquakes because a lot of work has been done here in the offshore domain to map the plate boundary, and we really cannot find one plate boundary. So what we have is a very complex network of faults. So different faults acting as a network accommodating this deformation. So it's one of these plate boundaries that is commonly named a diffuse plate boundary. And actually, we don't know where the 1755 earthquake happened. We don't even know where the 1969 earthquake happened, in which fault. So there's actually a lot of work to do there. And it's very difficult for us to understand this. We still have a lot of questions ourselves. And of course, it's very difficult to explain this to citizens and to students and to the population. Onshore, it should be really considered intraplate domain, and it has all the characteristics of intraplate setting. But again, a number of magnitude 6 to 6.5, 6.8 earthquakes in the historical record. So again, some of the largest intraplate earthquakes in Europe, and some of them with people with some memory in the historical culture. So actually, our outreach program is very turned towards answering the requests of people who come to us at different levels. Okay, this is just a map of faults to show that they are all slowly moving faults. So basically they are faults with slow motion, which means that they have long times pass between earthquakes because actually plate convergence is slow in this region. So earthquakes here really are low probability, high impact events, or they have the potential to be that kind of extreme events. So we receive a lot of requests to do outreach at all ages, and as all of you know from your outreach experience, you can spend endless resources in outreach, and we've done a big effort to try to structure this program such that it consumes not all of our time, so that you can keep it manageable for us. And in doing that, we understood some differences in the way different groups deal with earthquake and earthquake risk and earthquake science. So in our experience, the kids, before they get into adolescence, they have a very high risk perception, and they are very open to learning about earthquake risk because kids really, for them, the fact that they've never experienced something is not a barrier to believing that it exists. Whereas when you enter teenagehood, actually risk perception goes down very strongly, which is why teenagers do the things they do. And it's really not very, I would say, not very profitable to insist on risk because it's really a time to continue what you've done before, but you have to change the shift of your information to science in our experience, because then during teenagehood their cognitive abilities develop very strongly. And they really, it's much more profitable from our experience to talk to them about science. And then once they become adults, and actually even college students, and they feel the responsibility to teach younger students, they actually get an enhanced perception again of risk and of science. So we try to focus on educating the professionals that can then teach the lower levels. Although we do some activities for high school students and actually from preschool, because we like having that feedback and that experience, but we try not to do that too much. Okay, so in professionals, we deal a lot with teachers, and let me see, okay. And we deal also with civil protection and actually with private companies that have business continuity departments. And for example, the Electricity of Portugal, who have museums for education. And so we try to support those kinds of professionals. So before I go on to civil protection, I want to tell you a little bit about our experience with schools, because again, for us, we get requests to support schools, so very different from other countries. We've had teachers who have built their own seismometers. We have a teacher who is currently building a seismometer, so it's a geology teacher in partnership with a physics teacher. They have workshops at schools. So you really get very interested and very motivated teachers who want to do things, and they come to us and ask for support, and we try to support them. In terms of curriculum, we actually teach seismology in geology and biology courses. So the group where it is in is biology and geology. Most of the teachers actually have a biology background, and they have to teach seismology, which has, you know, is in the interface between physics and geology, but it has a lot of physics. So they have a real issue with teaching seismology. It's very difficult for them. They don't have the adequate training. So we try to do training for them, and it's always very well received. And right now, I think there's a big opportunity for seismology in schools, at least in Portugal, but I suppose it will not be the only case. We used to have very extensive curriculum in high schools. And so it was very difficult to get through all of the material they had to cover. And right now we have a backlash on that. And we have a new curriculum on implementation where we have these national common goals, which are much less than what they used to be. And then schools actually have the freedom to implement the rest of the curriculum, which should be based on projects. So in those projects should be multidisciplinary, interdisciplinary. And actually, teachers have to think about projects where they can put together math and physics and geology or biology. That's a huge challenge for teachers. I know of a number of schools who have started, and they have difficulties to identify these projects. So we are trying to push seismology forward in these, because we think seismology is really one of these interface disciplines where you can really look at math and geography and geology, and for Portugal even at history, and for example Portuguese and how to write news. So it's really a very nice topic to work in an interdisciplinary fashion. Okay, so moving on from schools, I want to say one more thing about schools. So about keeping teachers motivated, we try to do a training session every year, which is about 1 week. We don't really do it every year because even us, sometimes we need a break from it. So I think that, you know, these cycles of enthusiasm, we need to take them into account as something natural and just, you know, deal with it in a natural way. And so what we try to do at least is every year to have one day where we have half a day where we talk about interesting and exciting things in science, in seismology. So for example, we talk a big earthquake that happened or a new discovery, either regional or global. We have, for example, a PhD student who is doing a very interesting work. She's a biologist and she studies whales, but she's studying whales using OBS, so seismic sensors on the seafloor, and she uses triangulation and dispersion to locate the paths of whales. So we have her presenting her work. So we try to have some out-of-the-box things in seismology just to get people enthusiastic and excited about it again. And then on the second part of the day, we have teachers present what they're doing in schools and share their experiences. And it's a really good way to give them the stage and to show their experiences. Okay, so now moving on to the civil protection. Our civil protection in Portugal is organized in 3 levels, which is national, district, and municipal. Actually, the national level is undergoing a severe restructuring after the forest fires we had this year, which were really terrible, and they had a huge human impact. And we've worked mostly with the civil protection at the municipal level. So this is city level, and we have small civil protection units at the city level that really work on raising the awareness. And again, they don't have the training and they don't really understand earthquakes, and they come to us for help. And they do a lot of work. They do risk maps. So of course, they don't do them themselves, but they find the partners and they put them together. They do the information, they do training sessions, they come to us always for us to review what they've written about, for example, what is an earthquake, and we are very happy to help them. They go a lot to schools, so they really do a lot of specific training for earthquakes. And we do training for them. Actually, sometimes when you have training for teachers, they come to the same training sessions. So we just have training sessions open to teachers, civil protection agents, and even private sector people. And we participate in their events whenever we can. And they also develop their own materials. So I guess we have a lot of citizen scientists in Portugal. So this is a shake table built by a commander of the civil protection of one of our cities. They actually built two. They work very nicely. We actually made the cover of SRL a couple years ago with the project and how the shake table is used, because it's very interesting to notice what kids remain of their experience on the shake table and the common aspects of that. We, of course, once someone has one, everyone else wants to have another one. So following that, other civil protection started designing other ones, and here we are checking the accelerations on the shake table. These are other materials that they've developed, so they've done this on their own. We have a lot of educational materials at the university, so they often come, both civil protection and teachers, they look at our materials, and then they go back and they improve them, and sometimes then we copy what they did. So that's some of the materials they did. And for citizen seismology, I really see an opportunity here. This is QCN sensors in Lisbon. There's two, one at the university and the other one actually at the civil protection. And you can see here how they're doing on data, and they have a very nice continuous stream. So they are very good at keeping their stations running. They are people who really have an interest on this. This is their job, and they're trying to do it better. So I think it's a link where we can really get something from. And they actually, again, this is at the city level. This is an app developed by Civil Protection in my hometown. And they developed this app, and what this app does is that whenever there's something in the town, like an accident or something like this, they will send you information about what is happening. So again, some potential here for connecting or maybe finding some interface between this app and other apps that we have. But they are doing things, and they are very active. Okay, so that was it. So I think there's, regarding civil protection, two main points. They really have an interest to raise awareness and to get citizens to understand the risks that they are exposed to. Understanding risks goes through understanding the science processes and the science of earthquakes. And I think they can be real partners in citizen seismology. So that's it. Thank you.
Well, I'll ask you one. The books that get put out, where are they aimed? Are they aimed at primary school level or older?
The booklets?
Yeah.
They are for different levels. So you have typically one for kids and one for adults.
Thank you. My question is particularly in relation to the material you produce, and probably also for other people in the room who produce material for education, but that isn't in English. So I guess, first of all, I would say that for anybody that stands up on the podium for whom English is not their first language, absolutely brilliant. My heartiest congratulations, because we take so much for granted in terms of making presentations in English and forgetting, of course, that English isn't the person's first language. But apart from that, all of the education material that's produced it would be great if we could maybe gather all of that together, and for the material that isn't in English, help these countries to produce this information also in English. A lot of the time we find ourselves reinventing the wheel in relation to material that needs to be done, and maybe a coordinated or concerted effort towards consolidating all of that material might be a possibility that we could look at in this room. Thank you.
Yeah, I think that is really important, not to reinvent the wheel. And we have this issue even even within our team. So, you know, keeping track of what we have already done and not doing it again. I think this compilation of materials is being done. It's one of the goals of Project SERA, of this work package. I want to say also one thing that I forgot to say, that we do with schools that works very well, is that we have a lot of educational materials at the university, and we try to have them replicated. So one set of materials always stays with us, and the other set of materials, actually, schools borrow them from us for a week, for example. And we have lots of them, like a tsunami tank and things like this. And they go to schools, and then they come back. And so it works very nicely, because schools don't have to do the materials themselves, and they can just borrow and take it. And concerning also the materials, I think in addition to having them compiled, in one same repository, it's very nice to have the ability to edit them and to translate them. For example, we have translated some of Ari's materials. We had a very interesting experience with kids from art who translated one of Ari's videos. And they were very into it because it was a media thing. So they were, you know, talking, and then it was actually, it worked very well. And these were kids from arts, and their feedback was that they really didn't care about science, but they had learned a lot of it from that experience. And it works very nicely, because then you have the videos taught by kids. And when you listen to a video spoken by a kid, both adults and kids give more attention. So it's actually a very nice activity to